Hello everyone, my name is Bartek and I work as a machine learning engineer at Software Mill. In my free time, I like to code, what must be very surprising for all of you here, read books, and from time to time do something related with mathematics. And it is one of the reasons why we all here today. I would like to tell you about one of these peculiar mathematical curiosities that can actually impact our life as software engineers. And I will try to answer the question why calling allMatch on empty string will always return true and what it has to do with math. But before we start, let's go through the levels on which math and software intersect with one another. So let's start from level 0, because we should always start numbering from 0, we are developers. So we have binary system, so ones, zeros, and all the algebra related to hardware, so basically making our software runnable at all. Then we've got things like algorithms and data structure, which are heavily based on mathematics. In fact, some of them even originate from mathematics as a science instead of computer science. And then on the second level, let's say the architectural level, we've got things like CAP theorem, which, besides describing some basic trade-offs we have to make while designing the distributed system, is also a fully proven mathematical theorem with all the required paperwork. And as a cherry on top, we've got monads, functors, applicative functors, and all other mostly not understandable pure functional programming stuff that most of us not fully understand, yet we are happily using it in our day-to-day life as software engineers. But let's go back to basic question. Why calling allMatch on empty string will always return true, and what it has to do with math? So the reason behind this is vacuous truth. And it is a purely mathematical concept that originates from branch of mathematics known as logic, and is used to describe all the logical statements that are evaluated as true because their base condition or antecedent cannot be fulfilled. Or in more mathematical syntax, let's assume that we have a logical statement S, if P then Q. Then, if P is false, S is logically true and is considered vacuous truth. We can also write it with the help of the for all quantificator. And we get something like this. For all the x's from a set B, if Px, then Qx. And here, if Px is false for all the x's, our statement is also considered vacuously true. So let's try to make it more descriptive with an example. So if there are any developers in the room next door, then they all work with Haskell. Maybe it is not the best example for empty sets because there are always were developers around us because we are on a programming conference, but nevertheless. The base condition here is if there are any developers in the room next door, and it is explicitly stated inside our logical statement. So if room is empty, the statement is evaluated as vacuously true and is considered logical true. We can also have implicit base condition. For example, in logical statement, all mobile phones in the room next door are turned off or turned on, doesn't matter in fact. And here, the base condition is that there are any mobile phones in the room next door. If there are no mobile phones or the room is empty, the sentence will be similarly evaluated as vacuously true and will be considered logically true. So now let's try to mix a little and mix this mathematical syntax with our Haskell Dev example. So Px is our explicit base condition that there are any developers in the room next door. Qx is our then clause, so they all work with Haskell. B is our set, so all the people in the room. And now we can write this in form of for all the x's from set B, if x is a developer, then they work with Haskell. Now I hope it sounds more easier to understand for all of you. But I was speaking a lot about maths, about some arbitrary developers, about some mobile phones. But how it all relates to Stream, allMatch, and Java? Basically, Stream is just this example with for all quantificator. That is why I put such emphasis on this case. And we can read it as for all the elements of our string B, if px then qx. And similarly to our previous examples with mobile phones or Haskell developers, if our set of elements of our string is empty, the statement will be evaluated as logically true and will be considered vacuous truth. And this is why it returns true always when called with allMatch on empty string. And here is a beautiful screenshot made by me in IntelliJ IDEA, which displays a compiler warning stating that we can just remove this expression because it will always return true. So you can see that even IntelliJ knew something about this concept. Of course, you can say that it's only in Java, it has nothing to do with maths. I basically made it all up for the sake of this talk. And here I am with a counterargument. In Scala, method for all, which is present in many collection interfaces, work exactly the same way. In JavaScript, method every from array prototype will also return true for empty arrays. In Python and Kotlin, built-in function all, which tests if all elements of an array are true, will also return true for empty arrays. And yesterday, when I was speaking with guys from Neo4j, we managed to find out that built-in function all from Neo4j will also return true for empty array. So when the hell freezes, math will be actually useful in our daily life, and vacuous truth in real life. Basically, all the absurdities which are based on obviously false or impossible to meet condition are vacuous truths. Besides, when a hell freezes, which I already used, we have when the pigs fly, when shrimps learn to whistle, when stars start rising in the west. To a degree, if I were you is also vacuously true statement. I know it is a figure of speech, but nevertheless, I will never wear you, so it is vacuous truth. And if we want to be 100% mathematical nerds, which we of course want to be, all of us, then we can count it as proper vacuously true statement. And as it is time to sum up this little talk of mine, vacuous truth is a concept from mathematical field of logic. It represents all the logical statement with a false base condition, is the reason why allMatch and their counterparts in other languages will return true for empty sequences, and as you can see a moment before, can sometimes occur in our real life. So, if you like my talk and want to stay up to date with what I'm doing, you can find me on LinkedIn, mostly, on Twitter under this handle, sometimes, on Software blog, and on DZone, where I'm trying my skills as a writer, from time to time. Thank you for your attention, have a great day, and have a great rest of the conference. If you want to ask me some question, I'm here.